Okay, so here's our first example. We need to go ahead and divide 7x over 2x minus 10, and then divide that by, I guess I should say it's more of a fraction of 7x over 2x minus 10. We're dividing it by x squared minus 6x over x squared minus 11x plus 30. First thing we want to do is we want to flip and multiply, or change it and multiply by the reciprocal. So that's 7x over 2x minus 10. The second one now turns into a times x squared minus 11x plus 30 over x squared minus 6x. And now we basically have a problem that looks identical to what you guys were doing in 6-3 day 1. So these problems right here, we're going to now factor, multiply across, and cancel out common factors. So I have a 7x over, I'm going to pull out a 2, because that's the greatest common factor, 11x minus 5, times, or multiplied. Up there we've got x squared minus 11x plus 30. So what multiplies to be 30, that adds to be negative 11. Let's see. 6 and 5, they have to both be negative. That took me a little longer than it should have, but x minus 5 and x minus 6 over. Now in our denominator, we can factor out an x, and we're left with an x minus 6. Now we can go ahead and basically draw this line all the way across. The reason why we can do that is because when we're multiplying together, we're just putting all those factors together. But we want to treat it as one big problem and then cancel out what we can. So I have an x minus 6 and an x minus 6. I have an x minus 5 and an x minus 5. Then I have a 7x. That x on the 7 and that x down below cancel. And all I have left literally is a 7 over 2. Now, this may look like our final answer. However, back in the core concept, it says that what we have in our denominator when our problem starts, we cannot have it be 0. So what does this mean? This means that we go ahead and see all of these pieces and see what makes them 0. Now, the easiest way to look at it is to check out those factors that we ended up canceling out. So that means this one right here, this x minus 5. What will make x minus 5 0? Well, if x equals 5. Therefore, when it turns to 0, we get an undefined answer. So we cannot have an undefined answer be our answer or our solution, even when we have it simplified down. So this means that x cannot be 5. And then we need to look at what else makes it 0. So looking at that denominator, which is when we flipped it, it's those pieces. So we already have the 5 covered. And what makes this x minus 6 turn to 0? Well, when x is 6. So x can't be 6. And then the last one we need to look at is that box right there, which is that x squared minus 6x. But when we factor it, we get x times x minus 6. We have already taken care of this x minus 6, but this x right here shows that we need to go ahead and say that x cannot be 0 as well. So all of these pieces right here will be asymptotes, say if we graphed this. Now I'm not having you graph it, but I'm just saying if we graphed it, we would have a line at 7 over 2, but every like the value at 5, 6, and 0 don't exist. So that's what we do when we go ahead and we look at the undefined answers.